Now we are getting onto quadratics. So this is the basic form of the quadratic. Now, of course, you guys know that there are different parameters for quadratics. So, as you can see here, the general form is y equals ax squared plus bx plus c. So, of course, the c here, pulling on from our last topic, is going to be the vertical shift. And then the a and b parameters are going to be dilation factors. They're going to dilate the curve. Typical questions that you're going to be asked in terms of quadratics is firstly to find the y-intercept, which of course occurs when x equals 0. The x-intercept, which of course occurs when y equals 0. And the x-intercept when y equals 0 is where we get to solving quadratic equations. So where we're using the quadratic formula and, you know, completing the square and factorizing. And that's because when we let y equal 0, we then have this equation in terms of x squared and x, which we can't just solve by itself. The other thing that you're going to be asked to find when you're dealing with quadratics is to find the turning point. Now, you are going to get to a method of finding the turning points without the formula later in the year, but right now you need the formulas to find the turning point of a quadratic, and we'll get into that as well. So we are going to go over solving quadratics, or in other words, finding the x-intercept, and also finding the turning points. So the first thing that you need to recall from year 10, hopefully when you learned it, is the null factor theorem. So the null factor theorem states that if the product of any two numbers is 0, then one or both of the numbers is 0. So intuitively, this makes sense, right? If you have 0 equals AB, where we don't know what A or B are, you know that the only way for this equation to be equal to 0 is if one of these is 0, right? That's the only scenario in which this equation is going to be equal to 0, because if neither of them were equal to 0, you would get a number. Even if both A and B were really tiny numbers, you still wouldn't get 0. So that means that A or B has to be 0. So, as I said before, solving a quadratic equation will give us the roots of the equation, or in other words, the x-intercepts. And there are three main ways of solving for x. The first is factorizing. The second is completing the square. And the third is the quadratic formula. So, these are the three ways that we will learn to solve for x. Hopefully some of them are familiar to you, but we will go over them again. Another thing that's important is to understand why we have two solutions, or why we sometimes have two solutions for a quadratic. So, remembering that the solutions of a quadratic are its x-intercepts, right? Because that is when the value of the function is going to be equal to 0. That's where y is equal to 0, the function is equal to 0. So an example of quadratics with two solutions might look something like this, or something like this even. As you can see, there are two clear cases where the curve intercepts the x-axis. A case where there is one solution might look something like this. So it just touches it once. Like that. A case where there are no solutions will look like where it doesn't touch the x-intercept anywhere. So it'll look like something like this, or something like this. So there's clearly no way that either of these quadratics is going to touch the x-axis. Okay, now getting on to the different forms of quadratics. So in your syllabus, it specifies that you need to understand all of the different forms that quadratics have. So, as you can see here, we have the form y equals a outside of x take b squared plus c. So in this form, the parameters a, b, and c tell us very important things about the curve, which makes it kind of easier to graph than a quadratic in the normal form. So, having a look at this curve, kind of going through the steps. If we first consider the most baseline part of it, which is y equals x take b squared, this is going to give us one x-intercept, one solution at x equals b, right? Because if we're finding the solutions, we're going to get 0 equals x take b squared, x equals b. So just according to this, we are going to get an x-intercept at, say, b here. Perhaps our curve is going to look like this. And then we're now going to apply our next step, which is the y equals x take b squared plus c. So now, of course, a plus c at the end is going to be our vertical shift. So perhaps we are going to now move our curve upwards, and of course this could be anywhere depending on the value of c. So as you can see here, this turning point is going to occur at our x value from before, b, and our new y value, c. So what this tells us is that for this form, the turning point is going to occur at the point b, c. Now, keep in mind that we are talking about b here. So if there was a, so it's important that there's a negative in these brackets. If, for example, these brackets were x plus 3, our turning point would occur at x equals negative 3, because there's a positive here. So to actually move it into this form, we would need to have x take negative 3 for it to be in the original form that we have up here with the negative. Okay. And then, of course, the final step is the a, which dilates the function. Remember, so that is going to stretch it or shrink it vertically. Okay. Moving on to our next form. So, if we just consider the baseline part of it, which is y equals x take b, y multiplied by x take c, then we are going to have roots at x equals b and x equals c. And that is because if we let 0 equal x take b, x take c, using our null factor theorem from previous slides, we would need to let x equal b and c. And if you are a little bit rusty on the null factor theorem, that's okay. We're going to get to it when we get into factorization in the next slide. And then, of course, applying the other element, which is the a value at the front, that's going to be a dilation factor. So drawing this all together, we might have roots at b and c, and it might be dilated by a factor of a. Okay, so in summary, this format gives you the two roots, the two solutions, or the x-intercepts. At b and c, again, the negative there is important, just like it was in the last slide. Make sure you remember that. It's really easy to forget that there's the negative there. And then the a gives us our